All right, so on Thursday, we were talking about graphing linear inequalities. Today, we are going to talk about graphing absolute value inequalities. So, since they are very similar in that they come out of the same section of stuff, refresh my memory as to what we did on Thursday with graphing graphing linear inequalities. What did we do? What was that? I don't know. I asked a question and you said something. Oh, okay. Look back in your notes. What did we do? Linear was what I had said. Okay, so we changed it to an equal sign first. Is that what you're saying? Okay. All right. First we change it to an equal sign. Then what? What's the differentiation between the two? Okay. So if it's solid, a solid line on Thursday would give us. We'd have the equals component, less than or equal to, greater than or equal to, and a dash would be the other two. Okay, love it. Then what do we do? Where did we pick a point? But anywhere else on the graph? Okay, if we can, we like use the origin. Okay, like it. And then what do we do with that? Plug it in where? The original inequality in this case, because we switched it to an equation, yeah? So we plug it back into the original inequality, okay? And then what? Shade it depending on the truthiness of that point, right? If that point was true, we shade on the side of the line with that point was on. If it was false, we would go on the other side. Okay? Love it. We're going to do very much the same thing today, with the exception of, now we're going to tweak it, and so now we're going to have absolute values. So absolute value graphs look like what? They look like V's. Yep. Okay, so there's going to be a V. So instead of being on one side of the line, we're either going to be inside the V or outside the V. Okay? But the steps are exactly the same that we just talked about. First, we're going to graph the absolute value as if it were an equality. We're going to still draw the rays. The sides of the absolute value are still either going to be solid or dashed, and that's going to be dependent upon what kind of inequality we have. If we have a less than or equal to or a greater than or equal to, it's going to be solid. If we have less than or greater than, it's going to be dashed. Just like before. After we get the absolute value on our graph, we're going to pick a point not on the absolute value. And we're going to test it. True says we're going to test to that side, so it's either inside or outside. False says we go to the other one. Okay? So everything's the same. It's just now that we've got V's instead of lines. Okay? So let's try this one. This one says we've got y is greater than the absolute value of x minus 1, then plus 4. Now, thinking farther back than Thursday, if we think back to earlier last week, when we were graphing absolute values, we had two ways to graph an absolute value. One was the T-chart method, the mathematical method, where we picked a bunch of points, plugged them into our equation, found the corresponding y's, and then we graphed those points. The other way was the logical way, where we looked for the vertex point based upon the equation. Where in this one is the vertex point? 1, 4, is that what I heard? Okay. 1 and 4, just so you know, for those of you that said that, 1 and 4 are two different numbers. Okay. 1, 4, as some of you said, is 14. Okay. 1, 4 is the point 1 to the right of the origin and then 4 up from the origin. Okay. So there's a different distinction on the different ways that some of you said that particular point. Okay. 1 and 4 are two different numbers. 1, 4 is 14. 1, 4 is that blue dot on the screen. Okay. Then, after we find the vertex point, we find the right side slope. What is the right side slope? 1. Then we find the left side slope. Which would be -1. Solid or dashed lines? They're going to be dashed. Test point. What did we just talk about for the first mod of class today? What did we talk about? What did we talk about? We talked about doing better. Are you doing better by sitting there and texting your mother in the back of the room? Is that doing better? Is that doing better? Yes or no? Is that yes or no? Okay, so why do you do it then? Why? So, what does it have to do with math? No, because apparently your text messages are more important than class. So yes, we're going to wait for you to finish answering your text messages. Then put your phone away, like I asked you the first mod of class. It's not that hard. Now what do we do? Pick a test point. What test point you want to pick? 0, 0. Okay, I love it. Love the origin. Anytime we can use the origin, for sure, let's use it. Okay? So I'm going to plug 0, 0 back into my original equation. And my test point is actually going to be located there. So if I get a true test point, I would shade outside the absolute value. If I get a false on this test point, I'm going to shade inside the absolute value. Okay? So if I plug that back in, I get 0 is greater than the absolute value of 0 minus 1 and then plus 4. 0 minus 1 is -1. The absolute value of -1 is +1 plus 4 is 5. Is 0 greater than 5? No, that's false, right? So since that is false, we are going to shade then inside the absolute value. Oops, that wasn't good. Restart that. Right over the top of my line. And that's what our graph looks like. Love it. Okay? What I'd like you to do now is I would like you to try graphing this particular inequality. Vertex? Right side slope? Right side slope is what? Negative 2. My left side slope? Positive 2 then. Yep. Okay. So I'm going to go there and there, there and there, there and there. Solid or dashed line? Solid. Test point. Use the origin. Okay. 0 less than or equal to negative 2 times the absolute value of 0 minus 3, then plus 2. 0 minus 3 is negative 3. Absolute value of negative 3 is positive 3. Times negative 2 is negative 6. Plus 2 is negative 4. Is 0 less than or equal to negative 4? True or false? That is false. Yep. So that is, once again, an inside shading.
How'd you get negative 4?
How did I get negative 4? Okay. 0 minus 3, negative 3, right? Absolute value is 3. Times negative 2 is negative 6. Plus 2 is negative 4.
So the absolute value before you multiply by the negative 2, right?
Correct. True, you shade on that side of the point. False, you shade opposite side. In this case, it's inside or outside. Okay? Why did I use the 2 instead of the 3? Oh, for the slope, because the slope is the outside number. This A value outside is the slope. That one right there is the slope. Yep. Yep. The other two give me the vertex point. Okay? Try that one. Vertex? 4, 0. Do we like 4, 0? I like negative 4, 0. Right side slope, 1/2. Left side slope, solid or dashed, dashed. Test point, use the origin. Okay, love it. Do we have to use the origin? No, don't have to, but if it's just easier if you do, as long as your absolute value or your line doesn't go through it, that's fine. So that would be 0 less than 1/2 times the absolute value of 0 plus 4. 0 plus 4 is 4. Absolute value of 4 is 4 times 1/2 is 2. Is 0 less than 2? Yes, that is a true statement. And so since my test point is outside the absolute value, I'm going to shade the entire outside of the absolute value. Okay? Questions? Fantastic. So today I am going to give you 2 homeworks. This homework is due Wednesday. The black homework is your review homework. That one will be due on Thursday. Okay. So I will also be giving you 2 sheets of graph paper, one for the orange homework due on Wednesday, one for the black homework due on Thursday. I will also let you know that yes, there will be a formative assessment tomorrow in the Math Resource Center. Okay? We, frankly, after grading your quizzes, you guys need more practice. Okay? You need more practice. So we're going to give you more practice. I'm talking about me. I'm going to give you more practice. Okay? Starts with this. Starts with doing your homework. Doesn't start with copying your homework. Starts with doing your homework. Okay? And then using the stuff that's posted online as a guide, as a resource. Okay? Right? Not using it as you're doing it, or not having it done for you. Okay?